I guess a broad umbrella or broad question is, who's doing the thinking? So our big question is, what is STEM and what is it not? So we Googled a good STEM activity and came up with this picture there. The activity was given to each table, and it was very directive. Just follow the instructions and you would achieve your goal. We then even had a picture, so you knew you didn't even have to read, you could just build it from sight. We then asked teachers, was this a good STEM activity or not? And asked them to do what is STEM and what is it not. We asked them then to STEMinise that activity. So that meant to make it open, to make it broader, to give the questions to the kids. And a lot of people came back with creating a narrative. We've got a river, we have to get something from one side of the river to the other. How can we do it? Use whatever materials that you need to do. And the links were into forces in the science curriculum, and engineering to make whatever it might be to transport the object across. The mathematics would be in measuring the river distance, etc. So what people came up with was far more richer than what was actually here. We then talked about it's so important in STEM to be problem finders. We talk about problem solvers all the time, but we need those people and kids to have the insight into what are the problems here and how can this be made better. And as you can see on the slide there, a good question invites children to think and to be creative. And to be problem finders as well as problem solvers. So here's an example of a problem finder. So, the food that we eat is being sprayed by chemicals, and the chemicals are so toxic that the people who are spraying them need to be covered up completely. And then showed this video of a solution to that problem. So the robots identify the weeds and just take each weed out with a minimum amount of spray. So we then talked about how do we create problem finders and problem solvers, and how do we create deep thinking? And deep thinking only occurs with dissonance. This was a question put to the people there. To create dissonance, we create juxtaposition, and the brain will automatically try to create resonance and harmony. So when ideas, images, etc. are put together in contrast, in juxtaposition, we create cognitive dissonance. The greater the contrast, the greater the clash and the discomfort, we're thrown off balance, and the brain wants to come in and solve the problem and create harmony. So we create dissonance by showing a scene like this. Now, this was done in our junior primary classes, showing a scene like that, showing another beach scene like that, put it together, and the kids automatically want to ask questions, want to solve the problem. How do we fix this? Why is it happening? And they're doing a whole unit on removing plastics from the environment. Another one here, pictures of pelicans, another picture of a pelican, and the emotional link there to see a dead pelican is profound on the kids, and it spurns them into wanting to do something about it, so looking for solutions. So great problem finding and problem solving.